Assalamualaikum. So today our group will be presenting our final project. So my name is Groot. This is my group members. This is Shakir and this is Shada. So we will proceed to our first slide. So before that, this is the introductions about our project. So basically, we will using statistics studies in our project because statistics is study of collections, analysis, interpretation, presentation, and organization of data. So meaning to say we will collect data and analyze our data using statistics. So our UPM Sports Center will organize an event which is called SUKOL. So this SUKOL for session 2019 and 2020, they will be having track and field. They will be going next semester. So they need to select students from both females and females. So the real problem is that only 30% of 10 college students who will actually come for the selection. So this number is quite low. So in order to help them, we run experiment and we come to them. So the selections or the experiments, it takes a week to run these experiments because not every student has same schedule. And then from this experiment, we can take the time taken for students to complete one lab and determine the fitness who can actually fit to represent Thames College for SUKOL for track and field event. So the objectives of our studies is to determine the time taken for student jogging at Thames College, jogging track for one lap, which is 570 meters. And the second one is to find the fitness level of UPM students who can represent Thames College for SUKOL events. So next slide, I'll pass to Shana.
So for the hypothesis, you can see that the male students have shorter time taken jogging for one lap than female student, and the male students are fitter than the female students. And when the weight of the student increase in time taken, student jogging for one lap is increased, and when when the height of student increase, the time taken of student jogging for one lap is decreasing. So for the methodology, for our project, we conducted the experiment at the Thames College jogging track, and the track covers 570 meters, and each student have to finish one lap, which is 570 meters. And from that, we collected our data, and we can obtain the hypothesis if it's true or either true or wrong or false. And through that, the test of the hypothesis we used for methodology is descriptive statistics, hypothesis testing, linear regression, and probability. So this Shakir gonna explain about the test of hypothesis.
Okay, you can see that right here, this is all that we done during the experiment day. Then some of our friends helped us to get the time taken for one lap. Okay, next slide. Okay, we're going for result. This all the result that we got. And then we already got around 21 students for a week. Then because at the end of the semester, most of students got test 2 and then project to submit, and they got busy. So we can here you can see that we have weight, height, and then their gender, time taken to complete one lap, then how many they jogging per week. Then we state that they have warm up or not before they start jogging. Next, it's all the pie chart and bar chart. So a pie chart is about the student jogging at the college with separated male and female. Then among the 21 students, 62% of male and 38% of female. This one is pie chart. Pie chart of students jogging at 10 college track. You can see that male students quite higher than female, 13%, 13 students, and then females only 8 students. Okay, next bar chart is about the number of students jogging per week. Number of jogging per week, you can see that we have once a week, twice a week, 3 times, thrice, and then more than 3 times. You can see that only once a week have the highest number of students jog per week. Maybe they just want to jog for during the spare time, during the leisure. Right? And then the pie chart of students warm up or not. And then you can see that only 52 students warm up, and 48 students not warm up during the before they start jog. Okay, first testing is descriptive testing. From this, we use the Microsoft Excel to produce the data. And then we got the mean, median, mode, and also the variance, standard deviation, also the skewness, courtesies, and we calculate for 3 parts, which is weight, height, and time taken. And then this one is for both gender. We combine it, which is count for 21%. 21%. And then you can see that here it states that have skewness. Skewness for weight is 0.37, which is if 0.37 is between the negative 0.5 to 0.5. Which is symmetry. And then height, we have skewness negative 0.49, which is negative 0.49 is between negative 1 to negative 5, which is moderately skewed. And then for time taken to complete one lap, which is, we have 0.11, and it's between negative 0.5 to 0.5, positive 0.5, which is symmetry. Okay, next. And then this descriptive statistics is separated among male and female, and we have same as before. We have mean, median, mode, then courtesy, skewness. The mode for male is none, because none of our respondent during that day not have same weight, and a different weight. And then the median is 60 and mean is 77. For height, most of the male students have height 170, and then median is 170. The mean is the mean is 65.49, and then 23077. Sorry, okay. And then mean for height is 168, and for time taken they complete one lap, their mean is 202.46 seconds, and their mode, most of the students, male students, their time taken is 185 seconds, median is 196, and then here female, we have mean for weight, mean height, and mean for time taken 60, and most female, their weight is around 55, which, and then their height is 159, and the time taken to complete one lap is 9. So not all female have the same time taken. Okay, nice. So hypothesis testing, same as this one testing, we using the Microsoft Excel. So from this Microsoft Excel, we compare between using the t-test two samples assuming unequal variances, because we use that male and female, so different variants. They have different number because male have 13 number of students and female have 8 number of students. So we compare between two, and we have the T statistic and the T critical for one tail and T critical for two tail. And for this experiment, we compare for two tail, and we have that we set alpha is 95% is like usual, 95% confidence level, which is alpha 0.05, and then we can see that here we have T statistic is negative 1.4499, which is negative 1.4499 is smaller than 2.1098, which is not located in the rejection region. And then the value for alpha in alpha level in output also is 0.15, which is higher than or larger than the confidence level is 0.05. So we can conclude that this hypothesis we need to accept the null hypothesis. Okay, for testing number 3, we have linear regression. Linear regression, we compare between two time taken and weight versus weight, and time taken versus height. So we can see that from here we have weight the x-axis and time taken y-axis. So we have the positive trend line. Here we have the linear equation. Y equals to 1.1372x plus 135.83, and it stated that it's a positive because we have slope positive. And from here also we can conclude that the weight, when weight is increased, the time taken also is increased. No, right? Because when people have more weight, they have more load to carry, so it affect the time taken when they're jogging. So we have R squared is 0.2269. It's quite lower, and because it's further than regression line. And then we have the second graph, is time taken versus height. Time taken versus height, we have height which x-axis and the time taken y-axis. We see that the slope, the equation, linear equation is y equals to negative 1.3771x plus 434.7. So we can see that the negative slope. So you can see the trend line is decreasing. And then we can know that when the height is increased, the time taken is decreased. Because when people have high height, their leg is more taller, and they become more taller, and then they tend to have more larger step when they are jogging. So the time taken to reach the finish point is much shorter or lower. So we have the R squared is 0.118. It's also not quite good. It's further from the regression, right? So the next testing number 4 is we try to do the probability, and we sort the male and female, and jogging we choose the jogging per week because it have lots of choices, once a week, twice a week, thrice a week, and more than three times a week. We choose the more than 3 times a week because we want to select students that more fit, right? So maybe they jog more than 3 times a week. They much more fit than the others, right? So we want to calculate the probability that male that more than 3 times a week is 4/13 because male total of male is 13, and female intersect with more than 3 times is 1/8 because only one person try more than 3 times a week. So we need to calculate that probability that students jog more than 3 times, we plus it with the male and female, and we got 0.433. Thank you.
So to conclude, for the hypothesis, male student have shorter time taken to complete one lab than female student, which most of them is below 200 seconds, and the male student are fitter than the female students. So from that, the number of the male student jogging at the 10th college track are 24% more than the number of the females. And through the hypothesis testing, we can conclude that the null hypothesis is accepted, and it's not in rejected region. And through the linear regression, weight and time taken that student jogging for one lap is directly proportional, and the height and time taken student jogging for one lap is inversely proportional.
Okay, that's all for us.
Thank you.
Thank you.